Good morning, students. This is statistics, elementary statistics. Today is June the 27th. We're going to start a new chapter. We're going to work on section 1, chapter 3, 3.1. If you go to your assignments page or my lab statistics homework, you're going to see you have 3.1. By the end of today, you should be able to do problems from 3.1. We'll give you lecture on 3.1. I'll solve some of the problems from MATLAB in today's lecture. That's the plan. So, guys, uh, before we even read the whole thing, I want you to kind of understand these two words. We're going to hear them a lot: statistic and parameter. Okay. The word parameter is associated with the entire population. The population could be one class full of students. Population could be population of a state. Population could be population of a country, right? So the whole group. And I'm interested in that whole population. But sometimes the population is so large, I can't study the population directly. So what do? I grab or analyze a subgroup or subset of the population. I interview 100 people, and based on who I interview, I try to generalize. So when we have a characteristic about the population, generally a mathematical characteristic like the average age of the population, average weight of the population, those things are fixed. Whatever your population is, that's going to be their average weight. But you won't be able to you won't be able to weigh. Let's say you want to know the average weight of a VSU student. There's no way you'll be able to weigh all of them. You don't have the money, you don't have the time. What would you do? You would randomly select 100 students and weigh them and find the average. So this 100 students you're selecting is your sample. And when you find the average weight of this sample, that that thing, the quantity that you receive is called a statistic. Okay. A statistic is something we use to learn more about the parameter. Sometimes we won't have access to the parameter. Okay. We won't be able to find the exact average weight of the VSU students. It's too expensive or too time consuming. All we can do is weigh 100 people, 50 people, 300 people, and say, okay, we think that's pretty close. That's it. The larger the sample size, the better the statistic is, the closer it is to the parameter. All right. So, what does arithmetic mean? Basically, arithmetic mean is simply, I'm going to just give you a very simple example. Whether it's population or sample here, it's the same. Let's say I'm in a small graduate level class, okay? And the students out of 10, they got 8, 9, and 7. I have 4 students in a small graduate level class, okay? And these are the scores they received. So I want you to find the arithmetic mean of my class. That's what you would do. It is what you think it is. It is something you learned in middle school. Okay. Now, let me go ahead and find the answer. So it's going to be 16, 25. I think it's 32. I'm going to check it again. 9 plus 7 is 16. Yeah. So it's going to be 8. So that's how we find the arithmetic mean. Now, Now, think about this being a large class, okay? A large class. Let's say I have 20 students, okay? And I'm just going to grab 4 students randomly, and their scores are 8, 8, 9, 7. I do the same thing, and this time it's going to be called sample arithmetic mean, the arithmetic mean of the sample. All right. Population would be everybody. Sample is a subset of the population. All right. Wonderful. Moving on. Again, keep these are fancy words, parameter, statistic, all those things. So that's how we find the arithmetic mean. What else is going on in this section? This is, by the way, this is 3.1. So, okay, don't let this bother you. This is mu is something, this letter is called mu, okay? It's written like this, mu, mu. And generally, we use this letter to represent the population mean. Suppose there are x1, x2, xn, n observations. It could be very large if you're talking about a population. Then the population mean is you add all the numbers. How many items did you add? Capital N. And you divide the sum by n and you get the mean. This is called sigma. Okay. We're going to be seeing some of these a lot. Okay. So you want to be familiar with them. This is read sigma, it's summation. It simply means xi. I can be 1, 2, 3, so it's going to be xi. And that's another way of writing x1 plus x2 plus x3 plus x4 dot 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 to xn. Okay, so it saves you a lot of time. That's why we like it. All right, moving on. Again, these are slides from your 3.1. So what's median, guys? By the way, guys, let me make sure what we are talking about is today in this class is central tendency. Arithmetic mean that we talked about is a form of central tendency. Central tendency is informally, it's a form of average. So when a teacher gives an exam, he or she could be interested in what's the average of the class. Okay. Now, that's not the only way you find average. You can find average in another two, at least we'll discuss two more ways of finding average. There is another term, another way you can find the average. It's called median. How do we find the median? So let me give you some examples. Okay, just to let you know. In the book, there will be numbers with decimals, okay? They'll be tedious. And I will let you use Excel. I will use Excel at times. Otherwise, you'll learn a little bit about Excel. Otherwise, it's very difficult to do correctly. Feel free to use Excel. I will use it. I will try to share the screen with you and you will see how it can be used. But I believe most of you know how to use it. But now, for simple examples, I'm not going to use Excel. Okay, to find the median, let's say, again, I have 6 or 7 students. We're going to find out how many. Out of 10, this is what they got. Okay. This is what they got out of 10. I have 7 students in my class. It is a small graduate level class. I have 7 students out of 10 on a quiz. They got this. Okay. Now I need to find the median. Median means median means it's the middle point. How do we find it? So I'm going to rank order them, starting with the lowest and then going to the highest. So I'm seeing 5. Now you do it your way. Rank order 5, 6, 7, 7, comma 9, 9. And yes, you have to repeat 9, comma 10. Do I have 7 scores? Yes, I have 2 7s, 2 7s, 2 9s. Everything else is 1. Let's make sure I didn't mess up. So I rank ordered the data. Now, median is the middle value. What is that supposed to mean? I have 1, 2, 3, 4, 5, 6, 7. So clearly the middle value is this guy. So the median for this data set is 7. Done. The median is 7. Now, what if what if the data set had an even number of items? Let's say in my class, I have, uh, let's change the data set a little bit. Yeah, I have a student who got 2. Okay, so I'm going to go rank order it now. And this is my new rank order data set, right? I have 8 items here. I have 8 items here, but this time it's even. I don't have a unique median, a unique middle number, but I have these 2 in the middle. They happen to be 7. They didn't have to be 7. One could have been 6, one could have been 7. So I'm going to take the 2. If the data set has even number of items, data points, you will take the 2 middle numbers and find the arithmetic mean of those 2 numbers. So your median will be 7 plus 7 divided by, your median will be, which turns out to be 7. Okay? Now, 7 plus 7 is 14. 14 divided by 2 is 7. Well, it really doesn't matter. Suppose we didn't have 2 sevens, but we had 2 sixes. How would that change? I have 2 sixes, so this would be a 6. And my median would be 6 plus 7. Sorry. 6 plus 7 is, I think it's 6.5. Of course, you can use your calculator. So that's how we find median. Okay, not a very difficult concept. There's a third way we can find an, an average. I think it's called mode. I will do some, so let's go over it. Let's go over this before we jump to mode, okay? So this is what your book is saying. What I just did, it's nicely summarized in this. How do you find the median of a data set? Arrange the data in ascending order, determine the number of observation, and determine the observation in the middle of the data set. Well, if the number of data points is odd, it's generally the middle one. They're calling it n plus 1 divided by 2. It's the same. If the number of observations is even, then the median is the mean of the 2 middle observations. That's essentially what we did. So it's nicely summarized in your book. All right. A fancy word for you guys. So far, so far, we have learned about arithmetic mean, arithmetic mean, we will just call it mean, and median, okay? These are also called numerical summary. A numerical summary, well, these are examples of numerical summary. Um, we call, just a moment, median. All right, mean and median. Now, median is relatively resistance. What does that mean? Well, when you find the middle number, the extreme endpoint numbers don't affect the median. So median is resistant. So there could be a very large value, there could be a very small value. It's not going to affect the median. Median is more robust, more resistance. Those are the terms we use. And mean is less resistant. The large values and the small values, everything affects the mean to a certain degree, depending on how large they are, right? So mean is less resistant. Mean changes when any of the data points change, and um, median changes a little less, actually hardly any, by extreme data points. Now, when you find out the average cost of home in the US, people tend to use the median price. Median price simply means 50% of the homes sold above that, and 50% of the homes sold below that. So let's look up what's the median price of a home in the US today. Let's see. And let's see what that means. So the median price of a home, the median price of a home in the US is 440,000. Now, depending on who you are, it may seem high to you, it may seem low, but that's not our main point. Let's bring it here. That's not our main point. Okay. The reason we choose median because some of the homes in the US, if we found the average, if we added all the homes, let me write down. If we averaged all the home in the US and divided it by the number of homes, it'll be so large, most of us won't be able to relate to it. To be honest, even this number seems a little high to me. It was like 200,000 only 10 years ago. I remember. Anyway, so it's about 500,000. Half of the houses in the US are selling for more than 500,000. The other half less than 500,000. So this is the midpoint. Okay. Why do we use median? Because it's more resistant. It fluctuates a lot less. That's why sometimes for certain things we prefer this. But think about it this way, guys. If you take 4 exams in a class and I just look at your median score, you won't be happy because you want me to calculate every single exam that you took, right? Because your high scores will have a positive impact on your grade. So sometimes we prefer median, sometimes we prefer mean. I hope that all makes sense. All right. This is a good one, guys. Okay. So be a little patient here. This is hard. Okay. There are problems like this in your packet. Okay. So guys, if this data is skewed to the left means simply means there are lots of small values. Okay. The mean, since the mean is affected by everything, it will gravitate towards that end. If a set of data has a lot of high values, it's called skewed towards the right. The mean will gravitate towards that. And the median is roughly the middle. It stays in the middle, right? So if the data is skewed to the left, the mean will be less than the median. If the data is skewed to the right, the mean will be greater than the median. If the data is symmetric, both sides are roughly the same, mean and median will be equal. Do they mean exactly equal? Not really. They mean very close to be, excuse me, close to being equal. All right, guys? It's a concept that you really want to focus on and think about why it makes sense. Okay. If the data is symmetric, the left, some high values, some low values, they kind of even out. Mean and median will be very close. If the data has lots of high values, the mean will move towards the high value. Median will tend to stay in the middle by definition. If the mean is if the data set has lots of low values, the median will move towards the low values, hence it'll be larger than the mean will move closer to the low values, and hence the mean will be larger than the median. So you want to, this is just a slide that I screen captured your text. So make sure you kind of understand it. Of course, if you don't understand something, you can always email me about a question and I'll be happy to help you out. There's a little hard, a little perplexing, but it works. All right, the next one is very simple. It's probably the easiest of the central tendencies. These are also called central tendencies. So mode is a variable that's most frequent. Okay. So what does that mean? Okay. So I gave 10 kids an exam. Okay. 10 students. And these were the scores. I have 10 scores. Okay, out of 10, they got 9976729957. Now, this is the most frequent number. So the mode is the most frequent number. Doesn't have to be highest, doesn't have to be lowest, whichever is the frequent. So I'm going to say the mode here is 9. What if my data set was like this? What if it was like this? 3 of the kids got 9, and this kid got 2. Okay, so if this was the data set instead of the one I had, there would be 2 modes. Okay, the most frequent number is 9 and 7. All right, so this is called bimodal. Bimodal, 2 modes. Of course, it can be trimodal. We don't see that too much. Bimodal means a data set that has 2 modes, like the one you see right here. Okay? All right. So I'm going to pick a couple of problems from your homework packet. I'm going to do them. All right, guys? Um, let's try those. I thought I had it, copy pasted, but somehow I don't have it. But don't worry, we'll get to it. We're working on 3.1. And you're going to try some of these problems, right? All right, here's a good problem. I don't think this section is that difficult personally. I think it's a nice and easy section. So this should have a positive impact on your exam on the 3rd of July. I will use my calculator. Feel free to use your calculator or Excel. All right. I'm going to keep the answer here just to make sure I didn't mess up. Okay. Okay. All right. Let's see. Let's read it. All right. Let's read it. Mr. Zulu, Mr. Zulu finds the mean height of all 14 students in his class and in his statistics class. And just as he is finishing, Danielle walks in and her height is 67.5 inches. What is the mean? Okay, so we don't know exactly how tall the 14 students were, but we know that the sum of the 14 students, we're going to write it like this. Let's see if I can write it nicely. Sum of the heights, okay? Heights of the 14 students. Okay, the height part is very important, okay? Right? Divided by 14 must have given him 69.0. We are gonna, guys, what I'm gonna do, I'm gonna just change it. I'm gonna call it S. Okay, whatever S is. I'm gonna say S is, and I have to carefully define. S is the sum of the heights of the first 14 students. S is the sum of the heights of the first 14 students. Sure. Now, according to what he's telling, S divided by 14 is 69. Now I can multiply both sides by 14 and find the sum of the 14 students. All I have to do is multiply 69 by 14. And what do I get? I will use my calculator. 69 times 14. I'm getting 966. Now, Danielle walks in and she's 67.5. What is the new sum? Now, suppose the new sum, I'm going to call it S. I'm going to say T. Suppose T is the sum of the heights of the 15 students. What should that be? Shouldn't T be 966 plus Danielle's height? Excuse me. I'm going to change things around a little bit because I need the room. Okay, suppose T is the sum of the heights of the 15 students. So clearly T has to be 966. T has to be 966 plus Danielle's height, 67.5. And to find the new average, I'm going to find the sum and then divide it further by 15. Plus 67.5. I'm getting this large number. Now the question wants me to find the average of the new average of all the students. Well, easy. I'll say the arithmetic mean. I'll just say mean of the 15 students is that number divided by 15 and not 14. I'm getting 68.9. I think that was the answer. We're going to check. And you should put the unit or inches. Let me quickly check the answer. It is 68.9. That's kind of what we got. So we're happy. Take a look. I'll be right back. All right. Hopefully that makes sense. I'm going to do one more problem from your text. Okay. And let's go to your text. very similar, I think. Let me grab it here, like before. So let me sort it out. It's really supposed to be 44. Let's write it down. So let me grab this and bring it here. And let's work on the problem. A professor has recorded exam grades for 10 students in his class, but one grade is no longer readable. If the mean score on the exam was 80 and the mean score of the mean of the 9 readable scores is 84, what is the value of the unreadable score? Good one, right? The mean score on the exam. So 10 people. So the average of the 10 students is 80. If you multiply 80 by 10, you're going to get the sum of the 10 scores. So since we did a problem somewhat like this, we can go ahead and say sum of the 10 scores must equal 80 times, 80 times 10 or 800. All right. Now, sum of the 9's readable scores is 84. Sum of the 9 scores must be the average times the number of students. 9 this time. 84 times 9 is what, guys? Let me find out. 84 times 9, 756. So guess what? If you change them, this box has contains the sum of all 10 scores. This one contains the sum of 9 scores. If you subtract the two, you're going to get it. You're going to get what you're looking for. 800 minus getting 44. I think 44 was the answer. The missing score must be 44. So these are good questions, not really that difficult, fun. So guys, again, I don't have a whole lot to add today. If you are having trouble with any of the MATLAB problems, email me, ask for help. I'll be happy to record a video next class. So if you email me today, I'll be recorded next class. All right. So this was 3.1. You should be able to do all the problems from MATLAB. Please go ahead, try them. And I don't think this is a hard section. Basically, we have, in summary, we have 3 concepts: arithmetic mean, median, and mode. And we talked a little bit about resistance. We talked about parameter. We talked about statistic, all those cool ideas. Okay. And one of the good things about statistics is that it's a very relevant branch of math. We study it, we use it on a regular basis, right? When you're taking an exam, when you're taking a course, you're talking about statistics. When you're talking about average price of home, average gas price going up, gas price going down, you're counting on statistics. All right. Anything else? Email me. Other than that, I'll say goodbye. See you next class via the video.